Hi everyone. In today's lesson, we're going to talk about derivatives of sine, cosine, e, and ln. So let's start with a couple of definitions. The derivative of sine is cos, and the derivative of cos is negative sine. There is an easy way to remember once we have signs that change. So you're going to write on your paper SC, S, negative C, and it really just reads from left to right. So the derivative of sine is cos, derivative of cos is negative sine. Negative sine is negative cos, and the derivative of negative cos goes back around to sine. So let's see if we can use that to do a couple of examples. So the example to the right, find the derivative. So the derivative of sine, we look here, it's cos, so cos, and we keep going. The derivative of a 2x is 2, derivative of a constant is nothing. So keep going. F prime of x here, the derivative of a negative 2 cos. So I know there's a negative 2 there. Just treat it as if it was a negative cos. So you look at your value here. So negative cos goes all the way back around to sine. So because there's a 2 in front, it's just positive 2 sine of x. And then the derivative of this negative x, there's a 1 in front. So the derivative of that is negative 1. And the derivative of a constant is 0. Okay, derivatives of exponential functions. So the derivative of a to the x, or some number to the power, is that same thing times ln of the a. So I like to put this in words. This is same as the original times ln of the base, right? When we have an exponential function, a is the base, x is the exponent. And then e to the x, the derivative of e to the x is just e to the x, or in other words, the same thing as the original. So let's see if we can do this example. So find the derivative, f prime. So I want to take the derivative of this piece first. So it's a to the x, or 5 to the x. So we're going to do same, so 5 to the x, times ln of the base, and the base is 5. And then the second part, we're going to take ln, the derivative of e to the x, and e to the x is just e to the x. The derivative is the same. All right, second example, f prime of x. We want to take the derivative of 2 to the x. So that's the same thing as this. So same times ln of the base. So same times ln of the base. Base is 2. And here we want to take the derivative of e to the x, but I've put a number in front. So that just means we're going to bring that number down. So negative 4 stays down, and we take the derivative of e to the x, which is just e to the x. And then the next term is simply a power rule. 8 times 4 is 32. Keep the base and bring the power down by 1. Okay, so those are derivatives of exponential functions. And now we have derivative of log functions. So the way the log functions are, the derivative of log base b of x is 1 over x times ln of the b, or ln of the base. Log of ln of x is simply 1 over x. So the first one, if I want to find the derivative, log base 5 of x is 1 over x, so 1 over the inside, x is the inside. So 1 over the inside times on the bottom, ln of the base, this time is 5. Plus the derivative of ln of x is just 1 over x. That's it. Okay, the second one, derivative of ln of x, we know is just 1 over x. And this one, we can't take the derivative until we make it to the 1/3 power. So we're going to use a power rule, bring the 1/3 in front, keep the base, and decrease the power by 1. So 1/3 minus 3/3, that gives us negative 2/3. And then this last term here, we can't do until we bring upstairs. So we'll make this x to the negative 2. So we're going to do a nice little power rule. Negative 2 times in front is a negative, so double negative makes that a plus 2x, and then we decrease the power by 1, so negative 3. Okay, so these are 3 main concepts for derivatives: derivatives of logs, derivatives of exponents, and derivatives of 2 basic trig functions, sine and cos. So let's go on to the next page and apply them to solving problems. So I could ask you to write the equation of a tangent or normal line at a value. So we know that in order to find the equation of a tangent line or normal, we have the form y minus y1 equals mx minus x1. We need two things. We need a point and a slope. The point we can start with, we will use the original equation. So for the point, we always use f of x. So my f of x function, I'm just going to rewrite it, is 3 cosine of x plus sine of x over 2. I think it would be in your best interest to know that anything divided by 2 is the same thing as saying 1/2 times that thing. So that is how I'm going to actually write the original function. It's just going to be a little bit easier for me. And I want to evaluate this at pi over 2. So everywhere we see an x, we're going to put a pi over 2. Now, pi over 2 should be ringing a bell. We should be knowing that that is our unit circle. So my unit circle at pi over 2 up here is 90 degrees. That is the point 0, 1. So cosine of pi over 2 is the x value, and sine of pi over 2 is the y value. So the x value there is 0, and the y value there is 1. Don't forget to bring down the 3 that I'm multiplying by, and the 1/2 that I'm multiplying by. So 3 times anything 0 is 0, and 1/2 times 1 is 1/2. So 0 plus 1/2 is 1/2. So your point, f of pi over 2, is 1/2. Remember that corresponds to an x value of pi over 2 and a y value of 1/2. Here's your x1, here's your y1. So we're halfway there. We now need a slope. So to find the slope, we are going to plug into the derivative equation. So we first need to find the derivative. So we're going to take the derivative of cos. So it might be helpful if you want to put on top of your paper sine cos, negative cos. So the derivative of cos is here. We look to the right, negative sine. Since there's a 3 in front, it's simply negative 3. So negative 3 sine of x. And now here, the derivative of sine of x, we look here, is cos. It's okay that there's a 1/2. It's just going to be 1/2 cos of x. And we want to plug in, same spot, at this pi over 2. So f prime of pi over 2 equals negative 3 sine pi over 2 plus 1/2 cosine of pi over 2. So again, sine is the y value, which is 1. We multiply that by negative 3. Cos is the x value, which is 0. We multiply that by 1/2. 0 times anything is 0. 3 times anything is that thing. So f prime of pi over 2 is negative 3. That is your m value. So we're going to put this together to write the equation. So t for tangent line, y minus y1, which is 1/2, equals m, which is this, negative 3, x minus your x1, which is pi over 2, and that's your tangent line. Your normal line is the same thing, except we flip and negate the slope. So when we negate it, the negative goes away, we flip it, we get that, and then x minus pi over 2. So those would be my answers for my tangent and normal lines. So what I would love for you guys to do for homework is try these last 3 questions down here. Try to see if you can evaluate these limit definitions, and we'll start class tomorrow by going over these. All right, have a good night.